Okay, we will explore the machine learning life cycle in today's session. So it is, the typical application development. You take any application development, any software development project, they follow the life cycle, software development life cycle, right? As part of the software development life cycle, if you see the first phase is the requirements gathering, and the last phase is the deployment. Okay, deploying your application on the production environment. Okay, afterwards you will be monitoring, support, everything will be done. The first phase of the software development lifecycle is requirements gathering. So when it comes to machine learning, it's a problem definition framework. So the software development lifecycle here also, right? What we do is we gather the requirements. We try to understand the customer's pain points. Okay. So here, the first step is we define a problem. Okay, the new problem to address with machine learning. So this one helps us to quickly understand the elements and motivation for the problem. And also it can help us whether machine learning is suitable or not in terms of solving the problem articulated by the business stakeholders. Okay, so as part of the problem definition, the first step is we understand what is the problem and why does the problem needs to be solved. And second step is how we are going to go ahead and solve the problem. That is what we do it as part of the problem statement. For example, you are working for a realtor and he wants to he wants to basically he wants to predict the housing price. Let's say you are working for a realtor in Mumbai, so you want to predict the price of houses in Mumbai, given some number of features. For example, the location, and given the location and the size of the house and the total square foot and number of bathrooms and bedrooms. Based on these factors, you want you to predict the housing price in Mumbai. Okay, so this is what the problem statement. So at present, they are not able to predict, based on some mathematical equation. They are all doing guesstimate. Okay, so based on some, based on the guesstimate, right? They are doing it, but with guesstimate, you cannot your predicted value will not be accurate all the time. So hence there will be some proper mathematical equation or algorithm. If you use it and make the prediction, we can make sure that the prediction accuracy is very reliable, and it is near close to the ground truth. Ground truth is the actual value. Okay, as for the problem statement, we'll define so what we want to do. Okay, what is the problem, what we want to, why we need to initiate this project. As part of this project, this is the big picture. Basically, we wanted to predict the price of housing price in Mumbai, and some other scenario, like in some other cases, understand and predict product attributes that make a product most likely to be purchased. What factors which drives selling a specific product more in the market, right? So this is one of the requirement. And some other cases, right? How likely someone is click on an online ad. So you are an SEO expert, search engine optimization expert, and you do optimization everything. But somebody is asking you, right? So what are the chances, or what is the chances that the someone is going to click my ad in the online? So can you help me predict how many users are expected to click my ad? So these are the different problems posed by different department within a company, or different companies. They face different problems. To solve the problems, they come up with the problem statement. As part of the problem definition or problem statement, so as part of the problem statement, define the problem. Once they define the problem, and they will see if they can convert the problem statement into machine learning problem. That is the next step. So, and then what we do is we start extracting the data in order to create or build a machine learning model to predict the housing price in this case. Okay, and then what we do is, as part of extracting the data, we talk to the various stakeholders, and we will make sure that the source systems, right, the gold source, right? So they say the gold copy in the sense, so in my company we have 100 servers are there, of all those hundreds, which servers and which databases and which tables do I need to extract the data. Okay, so once you get to know the environment and once you extract all the necessary data, the next step is you start exploring the data. You conduct the exploratory data analysis. Okay, and this is the third phase. And the next one is data cleaning. Okay, and so now the question is, after extracting data, why do we need to do the exploratory data analysis? Probably after we do the data cleaning or feature encoding, can't we do? No, so before even you clean the data, right, you should be knowing how good the quality of the data. In order to, right, in order to understand that, you need to explore the data. So for example, use the box plot visual, and with that, you will be able to understand, okay, how many outliers are there in the given data set. Okay, and how do we address those outliers? And also, if you notice any missing values, and you come up with a strategy to perform the data imputation and so on. Okay, so unless you explore the data, how will you get to know the quality of the data? Whether the given data is sufficient enough to build the model or not, right? So before you perform the data engineering or the feature engineering or pre-processing, we explore the data to understand the quality of the data, and also we try to find out the patterns in the data. Okay, and the patterns in the sense insights. Okay, so you, by doing the exploratory data, you will get to know the insights by visualizing the charts also. Okay, okay, so now the next step is, after exploring the data, next step is you need to do data cleaning or scrubbing, and you need to do feature encoding as part of data pre-processing, and also you need to do this feature scaling. Okay, in today's session we will explore all the things. Okay, don't worry. And followed by this feature selection. After you do the feature scaling, feature encoding, data cleaning, everything, next step is you need to do the feature selection. What is feature selection? To take the subset of the columns, find out this best subset of the columns which can help predict your target outcome variable with higher accuracy. And those features that are not having predictive power, you can discard those features. So that is what we do it as part of feature selection. There are different techniques are available as part of feature selection. Okay, we will take a look at that also. And the next step is, after you do the feature selection, next step is you build and train your model. Okay, so right. So before you build and train the model, we have another step called choose the model. Okay, which model can I choose it? Okay, so it depends on the data that you have in your end. For example, in the case of a regression problem, you can go ahead with the linear regression, but you have a gradient boosted model is also available. With that, we can get higher accuracy. Even random forest model is available. Okay, so there are different types of models are available. So what we do is based on the root mean squared error. So which model error is less? Okay, so let's say the person A, person B, person C. I'm giving an Excel sheet to these three people. I just check of these three persons, which person's accuracy is more. The person, let's say the person B's accuracy is more. He estimated and he gave me the housing price. I could see the estimation accuracy is very high. That means the error is less. So that means the person B is good. So that's how we do the model selection. Whichever model has lesser error, which means higher accuracy, that is the best model, right? So we choose that model. And then what we do is, once you train the model, you evaluate the model. You train, apply the trained model on the test data set, and then you do cross validation. Supposing the given data is not a huge one, so what you do is you do tenfold cross validation, and you check the bias and variance. If the bias and variance are reasonably okay, right? So then you are good to go ahead with deploy the model. So if you don't have any overfitting or underfitting issues, or in case of overfitting, let's say you are going to use an algorithm called the regularization algorithm. You try with the regularization algorithm. With the regularization algorithm, if you are able to overcome the overfitting issues, right? Or different techniques that you use it to overcome. There are different techniques are able to overcome the overfitting issues. Okay, so after applying all the things, let's say if your model accuracy is good, right? So with the trained model and test model, the accuracy is good, then you are good to go with deploy the model. Once you deploy the model, okay, so the users can consume that one. For example, we are deploying the model let's say model in the app, we deploy the model as part of an app, Uber app. So somebody, let's say you want to book a cab from, let's say one place A to place B you want to go. You book an cab. So the cab automatically predicts, depends on the product, the traffic condition, weather condition, and also depends on the distance. Right. So it estimates the cost, right? The price, estimate the price. So likewise, once you deploy the model on production, it can be used by people. But in the case of training the model, what we do is we use the historical data to train the model. Okay. Fine. This is the high level overview of the machine learning model. If you take a look at the internet, so you can see different website, the different the phases they use it. This is the common phase. For example, as for a train model, right? So here itself, there are multiple steps. Also, you need to you need to split the data and train and test data set, and then you use the training data set. And what you do is, as part of before you train, you do feature scaling and feature encoding everything, and then you do it. But this is the and a high level, or it encompasses all the things, okay, into it. Okay, so the next thing is, see, other thing what you can see is, right, we evaluate the model, and then what we do is we have something like validation set. We use the validation data set to fine tune your hyperparameters. So they, include that as a separate phase. Okay, so as part of evaluating model itself, we take care of that one also. Okay, the hyperparameter tuning, everything we do it, and then we refit the model, and then we evaluate the model accuracy, and then if the model accuracy is good, and if the model can generalize very well, and if the variance is not high, then what we do is we deploy it in the production. This is pretty much about the machine learning lifecycle. See, what we did, we started with training the model, right, upfront. Training the model. In the case, I've used the linear regression demo, right? So in the case of linear regression demo, I've shown you how to load the data, and we did not do extensive data cleaning. We did not do extensive data analysis, exploratory data analysis. Okay, and also we did not do extensive feature selection. These three phases, I did feature selection and exploratory analysis. We just did it at a high level, right? So I have used sns.pairplot function. So that is more than sufficient for that given data set, because in that data set, we do not have many columns. The volume of data is also not so high. So, but what we do is usually we conduct extensive exploratory data analysis, and then we do extensive data pre-processing, because in the real-time scenario, the number of features are more, the volume of the data is also, more. So in that case, these steps, we spend more time, and feature selections, we spend some time. But importantly, the data pre-processing, we spend close to 50 to 55% of the time. Okay, the rest of the time, for example, 55 to 60% of the time we spend it here. And then what we do is what we do, and then only we spend remaining 40% to train and evaluate the model and the deploying the model, right? We spend only 40% effort. So with the 55 to 60% effort, we spend it in data pre-processing only. Okay. So this is pretty much about the machine learning end-to-end lifecycle. Now, what we will do is we will, directly jump into exploring what is a feature, or let's say, let's take a quick look at in each phase is what we do. Okay. So before I end this one, let us take a look at. So we know what is extracting the data. Let's say once the customer has given you the data sets, so in most of the cases they themselves will give you the data. In some cases, you need to go to their different environments and you need to extract the data. Okay, but there are some projects we did it like that. So they said they did not have time. They did not have people to help us, but they gave us a document. So with that document, they mentioned very clearly which all server, which data are available. And then what we did, we started, gaining access to those server and extracted the data. And then we just waited with customers. So whatever the data we extracted from these sources, are they correct? And if they say yes, okay, then the next step is exploratory data analysis. As for exploratory data analysis, we understand, the first step is we understand the given data set. Okay. And then we see in case of any data related issues. Okay, in case of any data related issues, right? We will see this when you use the charts like a box plot or even histogram, we will get to know what is the distribution of the quantitative variable. And with the box plot, we can find out are there any outliers are there. So in case of any outliers, still we go back to the customer, will ask them. So in these tables or via files, right? So we can see that outliers. Are they really, outliers, or is there any possible? Are there any possibilities due to some typo? The data was not, was showing something wrong. Okay, any problem with the typo? Okay, and also the exploratory analysis helps us to give a better understanding of the features and the relationship between them. Okay, for example, when you use the pair plot, right? The pair plot you can understand very clearly. So are there any relationship exists between the categorical variables? For example, your scatter plot. I'm talking about the scatter plot. Yeah. So, and also, right, with that we can find out are there any relationship exists between the quantitative variable or not. And also it helps us to extract the essential variables, and we can discard those features that are not relevant to my analysis. And also we can find the outliers, and we can address in case of any missing values or any outliers. We will have to address it in consultation with the stakeholders. If they say yes, the missing values are there, if they give the value data for it, then it is fine. Otherwise we need to do the data imputation. And in the case of outliers, we need to do something called capping that I'll explain you later. So that is what we will get to know as part of the exploratory analysis. Unless you explore, how will you know the quality of the data, right? How will you know whether the relationship exists between the columns or not? Okay, so that is what, so that's why this is one of the crucial phase as part of the data science. You have to explore the data extensively. Okay, and then next one is the feature engineering. It is also called as the data pre-processing, data transformation. Like they use different terms. All these terms refers the same thing. Okay, and as part of this, we will take a look at how to handle the missing values in the variables, and how to convert the categorical variable into numerical, since most algorithms need numerical features. Okay, for example, linear regression needs all the columns, including the dependent independent variables, should be numerical. Okay, in case of categorical variables or mixed with the numerical variables, if you find it as part of your independent variables, then you need to convert the categorical into numerical variable. So, and also we need to fix in case of you find any the distribution, data distribution is normal, you need to convert it to normal. Okay, because the linear models assume the variables should have Gaussian transformation, they're normally distributed. Okay, in the case of linear regression model, right, it assumes the target variable should be normally distributed. Okay, and also so the next one is finding outliers are present in the data, right? So how do we find out the outliers, and how we address them? Okay, so in case of outliers, can we truncate the outliers above certain threshold, or do we need to transform the data using some technique like log transformation? Okay, so those are the techniques that we use. And in some cases we use something called capping, and so the next one is scale the features. Feature scaling. So this is required to give equal importance to all the features, okay, and not more to the one whose value is larger, right? So unless you do the feature scaling, the machine learning model can misinterpret those features have more value, so that for that it will give more weightage. Okay, so to overcome those kind of bias, we need to do feature scaling. So net as part of the feature engineering, we do this kind of task. In addition to that, what we do is supposing that the data is not available in only one sources, so it is available in multiple tables, more than one table. You need to extract the data, and then you need to combine the data and sometimes you need to extract the data from other systems, and you need to combine the multiple files into a single file. Okay, and you apply some kind of business logic and create new features based on the existing columns, derived features. And these are the tasks that we do it as part of feature engineering. In simple term, any data related issues, we will address it as part of the feature engineering. In addition to data related problem, for example, if you wanted to create new feature based on the existing columns, that is also, we do it as part of the feature engineering. Okay. Now let us take a look at, as part of feature engineering, what other tasks that we do it. We do encoding, data encoding. So now let us take a look at what is encoding. So why encoding is required, different types of encoding, and how do we implement different types of encoding in Python. And finally, will summarize, right, what each type of, when we need to use which type of encoding. Okay. So first of all, what is encoding? Encoding is a technique of transforming or converting your categorical variables into numerical values. This I already discussed, right? But I did not show you how to implement them in Python. Okay, there are different packages that are available in Python, or classes that are available in Python to transform the categorical variables numerical values. Okay, so that it would be easily fitted to a machine learning model if you convert the categorical numerical variables. Okay. So before we getting into the details, let us understand about the different types of uh, the categorical variables. We know the types of categorical variables as part of descriptive statistics. I've discussed about it. There are two types of categorical. One is nominal and other one is ordinal. The nominal variables are variables that have no inherent order. In the case of ordinal variables, it has inherently, it has some kind of order in it. Okay, so we know very well the distinction between these two variables. So nominal variables, something, for example, gender. You have a column called a gender. In the case of gender, you have two categories. One is male, other one is female. And you have another column like mutual fund risk. In that column, you have something like, there are some mutual fund are categorized as high risk. There are some mutual funds that are categorized as medium risk. There are some mutual funds that are categorized low risk, high, medium, low. So in that case, though it is a categorical variable, the mutual fund risk column, it's a categorical variable, but it has some order in it. The medium risk mutual funds, right, or so compared to the high risk, the medium, the low risk mutual funds are so people can invest it there, right? So you can go and invest more on the low risk, but again depends, right? If the low risk but return is less, some cases the high risk high return will be there. Okay, it depends on the, but with the help of this categorical variable, you can understand which all mutual funds are high risk, which all mutual funds are medium risk, based on which you take a call. But the medium risk mutual funds are, the risk is lesser than the high risk mutual funds. There is an order here, right? Something is superior, something is inferior. So those kind of variables are ordinal, and gender kind of variables are nominal. Supposing you have some column, some other column like defect type. So yes or no, yes. So, or defect type also you have, let's say defect, yeah, defects. You have something called defect, right? So defective is defective. You have a column called is defective. In that, yes or no will be there. Let's say you are part of a manufacturing unit. You are, after producing the product, you are doing the inspection. During the inspection, your quality control manager, okay, you are doing the inspection, but there are some products you found some defects. There are some products you did not find defects. So in that case, you have a column in your Excel sheet. You say these are the products. Yes, yes means defective products. These are the products or no. So in this case also, right, we just classifying which all products are non-defective, which all products are defective. Okay, it doesn't mean the defective products are superior than non-defective products. Okay, obviously, right? So there is kind of the defective, non-defective products are, but here there is no rank, right? There is no rank. That is what I'm trying to say. But still, it is a nominal type of variable. Supposing the defect severity, you have a column called defect severity, high, medium, low. So in this case, there is a rank, inferiority, superiority. Higher the defects, higher the defects, yes, it is a very sensitive one. And lower the defects, the risk is less, right? So there is an inferior, superiority. There is a ranking here. So these kind of variables are falling under ordinal type of category. Okay, this is fine. So next, what we will do is, so let us take a look at what is the different types of encoding, label and binary encoding, right? This is one type of encoding. And next one is one hot and dummy encoding, and one hot encoding with many categories, target encoding. Different types of encoding is there. Okay, what we will do is we will take a look at the important encoding techniques, which we use it more frequently. Okay, so what is, we'll start with understanding one hot or dummy encoding. Okay, the categorical data are represented as vectors of zeros and ones. Okay, so create a separate dummy variable for each category and setting the value of the dummy variable to 1 if the observation belong to that category, 0 or otherwise. Okay, 0 otherwise. Okay. So when can we use this one? For example, in the case of gender column is there, male or female, right? So you can, but male, female values are there in the gender column. It is a categorical variable. It's a text data type. You cannot mix the text data type with the numerical variables as part of your independent variables. All your independent variable should be numerical, but I have a mix of numerical as well as the categorical variable. In that case, you need to convert the categorical variable into numerical variable. But the dummy encoding, what it says is, if you have gender column, so what you do is you create two columns like male or female. So whichever customers are male, you flag them 1, in that record, and then you flag them 0 in the case of female. Okay, so that is what your dummy encoding. So one hot encoding, okay, and so you basically we use zeros and ones. So binary and binary coding, okay. So to transform your categorical numerical. So another example is the region. In the case of one hot encoding, for example, given the data looks like this, okay. Customer has given you the data that looks like this, the invoice number. So invoice number 1000. So this invoice we raised in South region. This invoice we raised in North region. So we have a region column and we have something called quantity, price, and discount. So in this region, South region, in the invoice number 1000, how many quantities we sold, what is the price, and how much discount we have given. Okay, so here the region is a categorical variable. Okay, so what we are trying to do here is we perform one hot encoding on the region column. Okay, so in this case we have 4 categories are there: south, north, east. For 4 classes or 4 categories are there in the region column. So what we are doing is, for each region we are creating separate column. And then, for example, this record belongs to South region. So what you do is invoice number 1000. Since we raise the invoice in the South region, we flag this one. 1 means true, 0 means false. The invoice number 1000, we did not raise it in North. See, we raised it in only in South region, and we put flag, and rest of the region we put 0. Okay, so by doing so, if you look at each and every column, it's a numeric variable. We don't see any text in it, right? It's the quantity, price, discount. So in this case, quantity, price, discount, only these 3 columns are quantitative in nature. We cannot use the invoice number to train your model, okay? And we can use a region. Okay, region column is a categorical variable. So if you use these 4 independent variable, 3 of them are quantitative and 1 is the categorical variable. So hence you need to convert this a numerical variable for that. But here we have, it's a nominal type of variable. region is a nominal type of variable. It is not an ordinal type of variable. It is not that south is superior than north. There is no superiority, inferiority comes in picture here. It is a nominal type of variable. In the case of nominal type of variable, categorical variable, we perform or not encoding. Is it clear or not? Okay. Fine. How about Karthik is okay? How about others? Aruna and Jeevan. Aruna and Jeevan. Others are clear? Okay. Fine, right? Okay. Now we will see how we can implement them in Python. How we can implement them in Python. Because in Python, you have a host of packages are available to perform one-hot encoding. For example, I just go to the here I just go here, and what I will do is let me just open a new thing here. I have a file called salaries.csv because in this file I have the mix of both categorical as well as the numerical variable are available in the independent variables. Okay. And here what I do is I just take a look at the df dataset. df.head will give me the top 5 records. Df head. Okay. And this is the one. And now what I do is df.rank. So here I can see that df.rank. So look here. So in this file, we have 1, 2, 3, 4, 5, 6, 7 columns are there. Okay. For example, to check that, df dot shape. We have 7 columns, 2, 4, 6, 7 columns are there, and 397 records are there. In the case of rank column, I can see professor, assistant professor, associate professor is there. Okay. So this is a nominal type of variable. It is not that professors are superior than associate professor. Assistant. There is no inferiority, superiority here. Okay. All are employees. Maybe, there will be some kind of rank here. Okay. But this is kind of a nominal type of variable only. Right? Nominal type of variable. And discipline, we have some different types of disciplines are available. Yes, since PhD, the sex column is available. Right? Sex is also a nominal type of variable. And we can see the thing here. So now with this data set, we will see how we can implement the one-hot encoder. Okay. So there are 2 types of classes are available. One is the from category encoders import one-hot encoder. This is one of the class that is available here. And I just imported the one-hot encoder class. Here what I do is ex equal. What I do is df of rank. Only this column I want to create the one-hot encoding. Okay, what I do is some name I just give. So I'm going to create an object for this class encoder, one-hot encoder. Calls, we have a parameter called calls, and here I'm going to say rank. And the next step, what I do is I just say see features. I'm going to apply a function fit transform on the x variable. Okay, because x is in this case a rank. Okay, So I'm going to transform the data by applying the fit transform function. So the next step is I just print the CE features. Sorry, there is a one hot encoder. This spelling mistake here. One hot encoder, correct. Import name one hot encoders. Cannot remove one of from category. So this is from okay, one hot encode. So a lot of typo here. Fine, super, right? So we have a the package called category encoders are available. In this package, we have a class called one hot encoder. I have set up a object C one hot, okay, to instantiate this class. And next one is what I do is I apply the fit transform function on this data. So right, so this is the one the one hot encoder, right? This is the object, right? In this object, I have fit transform. So with this, with the help of this object, right, I'm going to apply the function fit transform on the variable x. Now look here, first record, look here, guys. If you cannot understand, I don't know, even 12th standard students, they were able to understand this one. See, if you are able to understand, you be generic. Say, I understood, right? You're not able to understand, don't be generic. Make it upfront. Sir, I did not understand here. So in this case, tell me what this one says, 100. What is this 100? So rank 1, rank 2, rank 3. This column, right, it did the one hot encoding like this, right? So in this categorical variable, we had 4 classes or categories. The rank, we have 3 categories: professor, assistant, associate professor. I know very well about the data, okay. And what happens here is, for the 3 categories in the rank column, it created 3 different columns. The column name is different. The naming convention is chosen by the package, okay. And here rank 1, rank 2, 3. So what does this 100 says? For the first record, it says the rank is 100. So what does it says? So what I will do is, I will, Professor, Parthik Professor, and Gilbert. How about others? So let me just do one thing here. Let me concat PD concat my data frame. I'm going to concat this with my data frame. Okay, and CE features. And without file, you need to say axis equal to 1. So we know the concat, we have 2 options. One is axis equal to 0, another one is, look here, now I made this features as part of my data set. If you look at here, now you should be able to tell. Forget about the rank column, because the rank column is no more helpful. It is not required. When you train your model, you're not supposed to use the rank column. Instead, you need to use rank 1, rank 2, rank 3. Okay, very good, Sumati. Okay, and here in this case, the first record, forget about rank, right? So this record in the rank 1, it mentioned professor. Rank 2, rank 3 is, it flagged it as 0. That means this guy is professor, is neither an associate or assistant professor. And if you go here with this data itself, we can understand. Look here, this guy is an assistant professor 1, right? With this data, you can see it here. That's why I concatenated that output with this one. Fine, you are able to get it right. So this is how you can do the one hot. You can convert your categorical variable into numerical variable by doing one hot encoding. But here the challenge here is you might be facing this issue. I know what Gilbert will ask. So the thing is, like, this when you try this in your laptop, it will say the package not available, not found. Okay, so in this case, what you need to do is what you need to type pip install category underscore encoder is equivalent to 2.0. Okay, so you can specify the specific version or the release of the package also here by using the double equal sign. On the right side of the double equal sign, you can specify this one. So what is this exclamation? So execute this command in the OS operating system. Okay, that is what this one says. Inside this, see, you don't have to go to DOS prompt, you don't have to execute it. So inside the notebook itself, you can tell Python, hey, this is an external command. So what it is, you take this command and execute in the operating system and install. This is the reserved word. Okay, pip is a utility using which you can install new packages. In my case, I've already installed it. Okay, I struggled a bit and then I was able to install it correctly. Okay, so pip install. Guys, here I just commented it. I will share this code to you all. You can also give it a try. Okay, and so that, but in your case, you need to uncomment it. You need to uncomment it and then give it a try. So apart from this, we have other package that is available to perform one-hot encoding. So what that one is sklearn pre-processing. Sklearn pre-processing is also one of the popular package from sklearn dot pre-processing. So this sklearn comes with the one-hot encoding tool, which is a built-in. Okay, the one-hot encoder class. Okay, import the one-hot encoder class. Encoder spelling correct. Okay, and what I do is let's call our class one-hot encoder. So in other words, right, we initialize the one-hot encoder object and assign it to a variable called OHE. One-hot encoder. Here I just say sparse equal to false. Okay, and okay, let it be there. That's all. So the next one is print over here, OHE, and we will see what happens. Is this working fine? Yes, one-hot encoder, right? So sparse equal to false, fine. And so we can see that in the output, it is an object of the class OHE, right? It is an object of the class OHE. Okay, that's what we can see it. So now I'm going to apply the method fit. The next step is OHE dot fit underscore transform, and here I said rank column. Rank column, but you need to make sure that you are using the extra square bracket. Okay, this is the one you need to make sure that. Okay, so now we are fitting and transforming our data using fit transform method. Okay, so in the output we can see that we have successfully converted our variable rank into a one-hotted encode variable. Okay, now I'm going to save this result. Okay, let's say I'm going to call a variable called feature array. Here it is slightly different. Okay, here 001, whereas here 100. Okay, so we need to understand. Okay, so here 001, the first record belongs to, so the third one belongs to professor. Okay, and the middle one is assistant professor. Feature array. Here I'm going to use the OHC dot fit. I just copy paste this one simply. Good. So now we are able to do this one. And the next step is, okay. So now you might be in a dilemma. So what this 0, and what this 1 is, right? So in order to understand this better, so in this thing, right, we have something called, if you want to look at the categories, right? So you can use OHE dot categories. Look here. So the 0 is related to assistant professor. This is related to, this is associate professor. This is assistant professor. The last one is the professor. So because you will get, you might get confused with this output and this word. But here, the one is for professor, it assign the one here, whereas here, we assign the thing here, right? here you can see the categories using which you can, but here there is no feature. I think there is nothing is available. Probably I'll check and tell you, okay, how to check the categories for this one. Okay, we can, I'll check and come back. But in this case, there is something called categories underscore. This is the one is available. So if you execute this one, you will get to know, what each column is all about. This belongs to associate professor. This belongs to assistant professor, and so on. So using one hot encoder that is available, that class which is available as per scale-on.processing, also you can do this one. And we have another option called pd.get underscore dummies, using which also you can do the rank. Okay. And now what we will do is, same way you can concatenate this one with your data frame. For example, if you want to concatenate this one with your data frame, you can do it that one also. In this case, OHE underscore categories, right? Okay, what I can do is we can create a data frame. Okay, for example, I have something called features is equal to pd dot data frame. The same way, let's say in this case, a feature array, comma, the df. Okay, and here feature array, okay, columns, or I can specify something like this one, sorry. Columns is equivalent to OHE dot categories. You can say that way also. Let's see what happens here. Yeah, say the feature. Okay, so here, okay, here, look here. In this thing, it is not, each column is not defined with the column header. If you want to define the column header, you can do it this way. Okay, so the categories, you specify the columns. You can use the data frame, pd data frame, and then the feature array, which has the array values. But to give some column name, right, you can use this way. You can do it this way. Okay. And next step is you can concatenate this one with the data frame. For example, I have, listen to my final data frame, right? So I'm going to update my existing data frame with this one, pd dot concat the df comma features. Importantly, axis equal to 1. So axis 1, what it says is column wise concatenation. If you specify 0, row wise concatenation. If you use 0, it will do the append one after another. Okay, but axis 1. So let's say you have 10 columns are there. Along with it, this one will get concatenated. So I just type df here, and we will take a look at, look here, the rank column discipline. Look here, the associate, whatever thing that we have given, right? So it got display associate professor, and it shows very clearly in the professor, it shows 1. Okay. So in this case, all these 3 columns are numeric variable. This is not numeric variable. Okay, you can drop this column, or for your reference, if you can retain it. But when you fit a model, when you build the model, you can use these 3 columns instead of this column. Okay, right? Fine. And we have gender column, sex, right? Sex is the gender column. So what I do is I'm going to use another method called pd get dummies. Okay, df dummies, for example, using which also you can do the encoding, get underscore dummies. The get dummies is available as part of pandas itself. df columns is equivalent to, I say, sex. Not SCD, it is sex. Look here, using get dummies. See, apart from one hot encoder class that is available as part of scale-on.pre-processing, and also you have one hot encoder that is available in another package called category and encoders, right? So you can, the one hot encoder is available in these 2 things. Whichever thing you need it, you can use it. But scale-on processing pre-processing one-hot encoder is widely used. Instead of that, you can use get dummies itself. So for this, you don't have to have the headache of import the class, and you don't have to create an object for the class, and you don't have to fit transform. You don't have to do so many steps. Simply you specify get dummies and you can do it. But the challenge with this one is for training and test data set. If you want to do one hot encoding, the skill and dot processing is the good one, because you need to do the get dummies for training separately and testing you need to do it separately. But in that case, right, the sklearn dot processing is much better. Okay, so most of them they use for one hot encoding, they use sklearn dot pre-processing package. As part of that, the one hot encoder class is available. That is the one is used. Okay, and next step is, okay, now the sex underscore female, I just want to rename this one as gender. Instead of sex, I want to rename it as gender. So what I do is I have something called prefix option, prefix. Here you can specify the to be column, what name you want to give it. Okay, and prefix is equivalent to the prefix separator. You have something with separator equivalent to dot. Okay, gender dot female, gender dot male, it will give you. Okay, column equal to sex df dummies. Look here, instead of sex underscore female, and you can define the separator. Either you can use dot or underscore, you can specify it. So using get dummies also we can do it. The encoding, okay, encoding you can see in the case of yeah, see in both the cases, right, whether it's a one hot encoding or, so we are doing the binary encoding, because these are all nominal type of categorical variable. And okay, the next thing is, okay, can I do the same for the rank? Look here, even for the rank, see this is, these columns we concatenated from the one hot encoder, but using get underscore dummies, also you can do the one hot encoding. But most of them, they prefer sklearn or pre-processing that one hot encoder class only for doing the one hot encodings, right? So, but PD, this is also fine. Get dummies, okay, but the problem is you need to do it separately for training and test, right? So, whereas with one hot encoder, you can do it together, okay? That is, and other thing is, okay, do I need to specify the columns separately, one at a time? So can't I specify more than one column at a time? Yes, that is also possible with get dummies. For example, you have something called rank, and you can see the sex here. Look here, rank dot female, rank dot male, and but again, so because I've given this one, right, it is giving this one, and instead you can remove this one, and then you just fit it, and then later on you can change the name. So look here, sex male, sex female, and rank associate professor, right? All the, you can do professor 1 now, and associate professor 001. So the get dummies and one hot encoder class that is available as part of sklearn.pre-processing, right? It does the same way, right? So 001. But whereas in the case of categorical encoders, it is opposite in the reverse way. The first it does the puts the professor 1, and then assistant professor 0, and then associate professor 0. The order was different in that case, right? The category encoders. One hot encoders and the PD get dummies, it does the same way. Okay. Fine. So in this demo, you have seen how to do one hot encoding for a single category, multiple category, like a rank and sex in one game. How can I do that? You have seen it. And then we have seen it, right? So, okay, next one is ordinal encoder. What if my column has order in it? This is an interview questions. See, all these are very important topic. Okay, so what I'm going to do is, in that case, I am pretty comfortable with the category encoders when it comes to the ordinal type kind of thing. Okay, encoders, import ordinal plus tab. It is not coming. Ordinal encoder. Okay, here you need to use something called mapping. Here I'm going to use a dictionary. So in that dictionary, key value pair. For example, column rank. I just specify the column is rank column. For the rank column, you need to do some kind of mapping. Key value pair. Mapping is the text value, hence assistant professor. Whatever the number that you want, you can specify the order. Okay. So here we simply specify 1, 2, 3. Associate professor. And then here I just copy paste this ordinal encoder. Dot fit df dot transform df. Okay, valid syntax. Here I've used true equal sign and mapping. Okay, here mapping. Okay, call key value pair. Okay, and I've okay. Here I should use. I've used this one. Oh, I just used it for this one, and this is for. It is not taking for that one. 1 second. What is any problem? Rank column should close. Okay, rank column should close, right? So Sumati, very good. Sumati became expert, very good. Oh, this is the one. Excellent, Sumati. Very good. So this is the one, right? Good. So now if you look at it here in the rank column, look here, everything got disappeared, right? So for the first one, we know very well, first record was professor. Look here, in this case, the rank professor is 1. The first record is related to professor. Hence the professor value we have given here, hence, it replaces the professor by 3. And 1 is assistant professor and 2 is the associate professor, because it displays only the top records. Okay, and that is what we can see there. Very good, right? It is doing the ordinal, for the ordinal encoder, it is doing the best job, a good job in terms of mapping or encoding the 1, 2, 3. Okay, the ordinal encoder is doing good job. So with this we can do it. Okay, so now we understood, how to perform one-hot encoding, how to perform ordinal encoders. In the case of ordinal variable, not nominal variable. In the case of ordinal variable, you need to use ordinal encoder. In the case of nominal type of variable like gender, right, in those kind of situation, you can use the one-hot encoder. Okay, and you can sit, for example, in the case of gender, you can, right, so you can use gender and all, right. Simply you can specify 0 or 1. Fine. Okay, so you can use it. Okay, here now the question is, why can't I use 1, 2, 3 even for the rank column? Okay, why can't I? So let's assume that in this case, rank is a categorical variable. Rank is a categorical variable. So that, with that assumption, we did the one-hot encoding. Okay, so instead of doing one-hot encoding, can't I, use 1, 2, 3? If I use 1, 2, 3, what it does is it will think, the professor is superior than this person, that person is superior. That there is some kind of inferior. The model will think the professor is superior than the associate professor. The associate professor is superior than assistant professor. Something like the model will think. It will start interpret this way. In the case of nominal term, that is the reason why you need to first understand whether the given categorical variable is a nominal or ordinal. If it is an ordinal variable, you can use ordinal encoder. If it is a nominal type of variable, one-hot encoder. It is as simple as that. Now the question is, we have explored three different packages like sklearn.preprocessing, categorical category encoders. So which one should I use it? So you can check the performance, okay, whichever the package that returns the value or does the encoding in a pretty fast way, that is the one use it. In general, we use sklearn.preprocessing. That is the one is very good one. And I would suggest you and explore how we can do ordinal encoding with the sklearn.preprocessing. That I will leave it to you, okay? You just explore it, how we can do it. Fine, we have learned how to do dummy coding in Python using pandas, get dummies and method and other classes also. And importantly, we have worked with the categorical data with 2 levels and categorical data with 3 levels, right? So we have seen it. And also we have seen how to perform ordinal, in the case of ordinal encoding, how do we perform the encoding? In the case of nominal type of, how we can perform the encoding, we have seen it using one-hot encoder and all. Okay, now the situation is we have something else called dummy code trapping. Okay, we have something called dummy variable trapping. So what is dummy variable trapping? The dummy variable trap is a scenario, right, in which the independent variables become multicollinear after you include the dummy variables. For example, in the case of a region, we have 4 categories: north, south, east, west. Just because we have 4 categories that are that were available as part of region, we created 4 columns. This is not the right way of doing it. So this can lead to dummy variable trap. Okay, so in that kind of situations, what we have to do is we need to do k minus 1. We need to create k minus 1 columns for the categories. Let's say you have k categories in your region column. So for that, you need to create only the k minus 1 columns. So 4 categories are there. 4 minus 1, 3 categories only you need to create the one-hot encoding. Okay, probably you can drop any one of the variable here. So this is the way, but now the question is, what is wrong if I create, let's say I have a k categories are there. For k categories, if I create k columns, what is going to happen? If you create like this, it can lead to dummy trap, variable trapping, which means there will be multi-collinearity issues. There is a collinearity, between the independent variable itself. That is one of the assumptions as part of linear regression. You remember it. There should not be any correlation exists between the independent variables. That means multi-collinearity. You will land up with multi-collinearity issues. This is called your dummy variable trapping. If you do it dummy encoding like this. So what is the way out now? So what is the way out? For example, okay, here in this case, you have something called drop. Okay, drop equal to first. For example, here rank, I've given rank, right? Here in the get dummies, we have an option called drop first equal to true. there is a parameter called drop underscore first equal to true. Okay, if I do it, drop. And if you look at the rank here, look at here, forget about these three columns. This one we did it using one not encoder class. Okay, this is using get dummies. Now what happened? Instead of creating three columns, it created only two columns: assistant professor, rank professor. It dropped the first column, the associate professor. Okay, so by doing this way, we can make sure that our encoding will not land or leads to dummy variable trapping. So in the interview, they'll ask you what is dummy variable trapping. In case of any multicollinearity, so look here, if a qualitative variable has k categories, what is a qualitative variable? Region. Okay, if that has k categories, in this case 4 categories, introduce only 4 minus 1 dummy variables. So 4 minus 1 is 3, right? So 1, 2, 3 are not supposed to have 4. If you have 4, it can lead to multicollinearity. You need to remember this simple thing, okay? Failing to follow the above rule, it can lead to dummy variable trap. It is the perfect situation of perfect collinearity. So here itself I mentioned, right? So which, okay, now the question is, in the get dummies, we have an option to drop first, right? We can do it. Is there any other option that is available in one not encoder itself? Yes, in the case of pre-processing, so sparse equal to, and here you can specify drop is equal to, there is an option called drop that is available as part of your one hot encoder class that is available as part of pre-processing. So, and if you do it this way, look here, and I just do it this way, and this is the previous one. I'm not going to disturb this. And now what I do is I just do the same thing here. This is for our reference. Okay, look here, in this case the first column got dropped. Okay, and you can see the OHE dot categories dot categories underscore. Oh, here, okay, that is available with that one. One second. Here, y dot OHE dot categories underscore, right? Yeah, so but still it shows the 3 columns here. Okay, it shows 3 columns, but end of the day you will have only 3. But in this case, it will be a little bit challenging if you wanted to concatenate these 2 columns into your data frame. Okay, that one is a little bit different, but with the first parameter, sorry, drop parameter, right? You can specify first column, you can drop it. Okay, in the one hot encoder. And similarly, here in the case of get dummies, drop first option is available. As part of get dummies, you can use that one also. So there is no harm in using get dummies in place of one hot encoder, but that is the one is used, that is the standard, right? Most of them, they use it because when you use the train and test data set, that is the best thing, okay? The sklearn dot pre-processing. Fine. Okay. The next one is what else we have? Okay, ordinal encoding also we have seen, right? So the each category assigned a numerical variable. In this case, label. Okay, how we can implement them in Python. So I have mentioned the script also here, which the package name, all the options also I mentioned. Target encoding, I'm not going to talk now because at this moment, this is sufficient. Even you have a lot of other techniques or feature hashing everything. So probably I will cover it later in the interest of time. But these are the important thing. Okay, the one hot encoding, and then so the sklearn pre-processing, right? And get dummies. If you know that, that is more than sufficient at this moment. We'll discuss rest of them later. Okay. In the case of target encoding, we encode the categorical values of the feature by using the target value. Using the target value, you'll be doing it. That we will discuss it later. Okay. And to summarize, you understood what is one order. It is the most commonly used method for nominal variables. The ordinal encoding is used for the ordinal type of variable. And we have something called frequency count encoders, feature hashing, and target, which we will discuss it if time permits in the later point in time. Probably in the later session, I will discuss about this. At this moment, these are the three important things you should be knowing. Okay. And dummy trapping also we discussed it. Right?